let's go on and look at the entrance ticket, because I chose this one here because I didn't realize that you'd be out until today. So I picked this one out of all of the other chapters intentionally. For those of you who are in Algebra 2, we just finished our chapter. We just wrapped it up yesterday for quadratics equation. So that's part of the reason I picked it. For those of you who haven't been in here or taken Algebra 2 since last year, it might take a minute. But the first one here, what are the values of x? What values of x are the solution for x squared plus 3x equals 10? If we're solving this here, the only way that we wouldn't move the 10 back over is if we're completing the square. For the ACT test, completing the square would be the last method I would choose to solve any of these here. Also, we see that all of the answer choices have the solutions as whole number answers. There was one method that we learned that works well if the answers are whole numbers, which was, y'all remember? Started with a G. XY coordinate plane, we would graph it, because we just need this equal to 0, and we can get it equal to 0 by subtracting 10 from both sides, which would tell us x squared plus 3x minus 10. Okay. And what I would do next is I would actually pull up the graphing calculator. Hit y equals x squared plus 3x minus 10. Because I'm going to have the graphing calculator graph the function for me. And once we get that typed in, if we hit graph, the solutions are where it crosses the x-axis. And we do have 2 points here. If we wanted to tell us the exact numbers, we can do second table. And we're looking for where the y values are 0. One of them is at 2 and the other is at -5. So we have 2 and -5. So the one with 2 and -5 is answer choice B. Question number 2, which of the following is a factor of the polynomial x squared minus 5x minus 36? Okay. When we factor a polynomial or a quadratic, we start with 2 sets of parentheses with 3 spaces. Well, we start off with greatest common factors, but since x squared is just x squared, 1, there is no greatest common factor. There's not going to be one here. The next thing is these signs. Since the 36 is negative, our signs are opposite. One's going to be positive and one is going to be negative. Now the factors of x squared are x and x. Now we just need to find the factors of 36. So that's 1 and 36, 2 and, not 2 and 12, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Now at this point here, we can try different ones, but 6 and 6 is not going to be 1. That's not going to work. That would make it a difference of perfect squares, because x minus 6 and x plus 6 would be difference of perfect squares, so we would look at the rest of them. We can try 4 and 9. And our check was to do the outer and inner. X times -9 would be -9x. 4 times x would be plus 4x, which gives us -5x. Is that what we wanted? So our factors are either x plus 4 or x minus 9. X plus 4 doesn't show up, but x minus 9 does. And the last one, what is the product of the two solutions of the equation? So the product of the two solutions of the equation, yes? Well, x squared plus 2x minus 15. What can we do? Because we want to know the product of the solutions. Why not just graph it? Because we can come over here, x squared minus 2x plus 2x plus 2x minus 15. Now we can go graph or second graph and look at the table. And again, we're looking for when y is 0, when the y value is 0. So when we look at this here, well, our two values where we have is -5 and 3. So the two solutions for this here is -5 and 3. So x equals -5 and x is equal to 3. And we need to multiply these together, which would be -15. And that is it there. You're welcome. So you'll have submitted those entrance tickets. Again, if you haven't or didn't have your Chromebook with you, get that done tonight. Get that done within the next day or so. Because what we're looking at today is factoring or expanding polynomials. Now, a quadratic equation is an equation whose highest term is raised to a second power. The biggest exponent that we have is 2. That is called a quadratic. We're going to call it a quadratic. A polynomial is an expression consisting of 2 or more terms. A quadratic is a type of polynomial function. Multiple terms added together. A binomial, well, bi means what? 2. Binomial is a 2-termed expression. An equation, 2 things are equal. Expression has no equal sign. Factor for any given number or expression that divides into it evenly. Now, we're going to go through factoring because I have found that most of these here, when we talk about factors, don't do it about the same way that I look at it. So we'll actually delve into how we do this here. Okay. Now this is the first one. We want to factor the expression x squared plus 7x plus 12. For those of you who have Algebra 2 this year, this is going to be a complete recap of what we just did not 2 weeks ago. For those of you who have not had Algebra 2, this will be a recap of Algebra 1, which you guys have covered before. We're going over it again. The main way that I look at factoring an expression is we first look for a greatest common factor. Is there a number or variable that will go into all of the terms? Well, here, there's not. X squared, the only number in front of it is 1. So there is not going to be a greatest common factor. We have x squared, 7x, and 12. There's not a variable that will go into all 3. So what we can do is start off with our two sets of parentheses with three spaces, because we're going to have two things multiplied together. The next thing we had was the signs, because what goes in the middle of both of these sets of parentheses would be the sign. It's either going to be a plus or it's going to be a minus, one of the two. Now, the way we figure that out is by looking at the third term. If the third term is positive, the signs inside these parentheses will be the same, and they'll match the sign of the middle term. So here it's plus, so they'll be the same and match the sign of the middle term, which is plus. So we'd have plus and plus. Now, when we're working with these here, especially if it asks you to factor it or find one of the factors, and it's listed as x plus a number or x minus a number, well, here, we already know it's going to be plus and plus, yes? So will any of the factors have a subtraction in it? Well, no, right? So that means any answer choice that has x minus a number is wrong. And we can mark those out. Now what we look for is the factors of the first and third term. Well, what two things multiply together to give me x squared? X and x, that's the only thing we have. Because there's not a number in front of x squared, x and x are the only factors that we have. Now the factors of 12 are 1 and 12, 2 and 6, or 3 and 4. Now at this point here, we're going to pick one, check it, try it out, plug it in and check it. We're going to plug it in and just check to see if it works. Well, which one of these factors do we want to try first? 3 and 4. And the last part is checking to see if this works. Well, x times x is x squared, yes? Well, where did we get x and x from? Well, they're the factors of. So should they multiply back together to give me x squared? So we don't need to check that. 3 and 4, well, 3 times 4 is? Where did we get 3 and 4? So the factors of 12, yes? So we don't have to check this or this, because that's where we got those multiplications, is where we got those from. The ones that we do have to check are here and here, because these two here will give us the middle term. So if we do x times 4, we get 4x. 3 times x is plus 3x. Now what is 4x plus 3x? So 7x. That's our middle term. Positive 7x, we got positive 7x. Those are the same, yes? So this here is the factorization of x squared plus 7x plus 12. And that's it. Now, the way that most look at it is that we would find all the factors of 12 and then work our way there. Now, the one right below it is asking us to expand the polynomial. I'm going to rewrite it back out. X plus 3 times x plus 4. We're wanting to distribute. X times x is x squared. X times 4 is plus. 3 times x is plus. And 3 times 4 is plus. And as we saw, 4x plus 3x is Let's look at the next one. x squared minus 4x minus 12. If we want to factor this, again, we look for greatest common factors. Is there a number or x variable that will go in all three? Well, no. So we write out two sets of parentheses with three spaces. Since the 12 is negative, our signs are one negative, one positive. Because if the third term is negative, the signs are opposite. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Now we look at the factors of the first and third. Well, the factors of x squared are still going to be x and x. Even if we do have a number in front of it, it's still going to be x and x, because that's the only way to get x squared. X times x would give us x squared. Now the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which one do we want to try first? We can try 3 and 4. And as we said before, or just a minute ago, x times x is still going to give me x squared. 3 times 4 is still going to give me negative 12. Those aren't going to change. But the middle one is what might. X times negative 4 would be negative 4x. 3 times x is going to be plus 3x. And negative 4x plus 3x would be negative x. Is that the middle term we wanted? No. Now, we could switch the 4 and 3, but that's really just changing the signs. It's not going to give us something different. So instead of 4 and 3, let's try the next one. 2 and 6. X times negative 6 would be negative 6x. Positive 2 times x is going to be plus 2x. And negative 6 plus 2 is negative 4x. Is that what we wanted? Yes. And we get this here. I'm not going to worry about expanding the other one. Let's look at this one here. If x squared minus 2x is equal to 15, what are the possible values of x? Really, here, our possible values of x are going to be in the list of plus or minus 1, plus or minus 3, 5, or 15. These here are really the possible values of x. Now, we won't delve into that quite yet because we haven't covered that in Algebra 2 yet. It's the Descartes, or Riemann's zeros, I believe, or Descartes zeros. Process of how we do that. But what we can do is get this thing equal to 0. So we can subtract 15 from both sides, which gives us x squared minus 2x minus 15 is equal to 0. And once we get it equal to 0, what we can do is we can grab the graphing calculator. Y equals, so we have x squared minus 2x minus 15. We can type that into the calculator and hit graph. And we have two places where it crosses the x-axis, because wherever it crosses the x-axis is what value of x will make this function equal 0. We can also go second graph and see where it's at 0. But one of the values is at -3, and the other is at 5. So the solutions are our actual x values is going to be x is equal to -3 or now we could have gone through and factored it, but this here is a little bit easier to just graph the thing. Any questions on this here? The next one, if x times 3x minus 11 is equal to 42, what's the value of x? What can we do first? Yep. So we can subtract 42 from both sides because we need this. We do need it equal to 0, which would be x times 3x minus 11 minus 42 is equal to 0. Yes. Then what can we do next? Calculator's not going to care. Because we can distribute and it would give us the answer just fine. But, interesting enough, if I go x, parentheses, 3x minus 11, close parentheses, minus 42. We have this here. Now, the actual function is 3x squared minus 11x minus 42. You only have to type the first one in. I'm going to type both in to just kind of demonstrate something. But if we type them both in and hit graph, there's the first one that we typed in. And there's the second one. Well, they just covered each other up, didn't they? If we go second graph and look at the table, well, the y values are the same. And there's one of the values at 6, yes? We did see it cross one more spot. Hold on a second. So 6 is one of our answers. The other one is a decimal number. And it's probably going to be 2 1/3. There we go. Negative 2 1/3. So we did see that x is 6, and the other is negative 2 1/3. Now they're going to go through and factor it down. Now, even if you get stuck on finding 2 1/3, if it's asking for both, and one of them is 6, well, anyone that doesn't have an answer of 6 can be marked out. And just by looking at the graph, we could see where it crossed the x-axis was between -2 and -3. So we're looking for an answer that is between -2 and 3, and something close to -2. Since they do provide us with answer choices, most likely we can find one that fits that description without having to go through the whole process of finding -7/3. And those are the two possible choices. All right, let's look at one where they actually give us answer choices. Through the forest. What values of x are solutions for the equation x squared plus 7x minus 12? So what would we need to do first? Add 12 to both sides, which would give us is equal to. So, yes. Yes, but almost. Because if we did that, we would have x plus a number times x plus a number, yes? Now, according to zero product property, if any two things multiply together equal 0, one of them must be 0, yes? So x plus our number would equal 0, and x plus our number would equal 0. But to get x by itself, I have to subtract whatever that number is from both sides. So we would have a negative version of whatever our number is for both, which means the actual correct answer is A. Because for factors, it would be plus. Now, x squared plus 7x plus 12. We could come over here. Y equals clear, clear. And we can go x squared plus 7x plus 12. Second graph. Well, let's just do graph. So it does give us where it crosses the x-axis at the 2 points, yes? And we can see here that they are both negative. So our two solutions, so the only one with two negatives is -4 and 3. Those are the correct answers. Incidentally, if 0, because here B and C both have 0 as a solution, the only way that 0 is a solution for any type of quadratic equation is if there is no constant term. There is no term without x or without the variable. So if we'd have just had x squared plus 7x equals 0, then 0 is a solution. That's the only way 0 can be a solution. So looking at this here, because we do have 33, 0 is not a solution. 0 cannot work. Now the first thing we need to do is to subtract 33 from both sides, which would give us x squared plus 8x minus 33 is equal to 0. I would go on and graph it. Because is it possible for us to get a solution with imaginary, fractional, or irrational answers? Well, what are our answer choices? Well, A is both whole number answers. B, C, D, and E, all of these have whole number answers. There are no fractional, imaginary, irrational solutions. So that means graphing will work. So again, we can pull up the graphing calculator, go y equals x squared. And this here is going to be plus 8x minus 33. Graph. So we see that it is coming up through 3, yes? A quadratic is always going to be a U-shaped graph, either opening up or opening down. Now we do see one of the solutions is at 3. So it's either going to be 3 and 11 or 3 and -3. So if we go second graph, 3 is a solution. And -11 is also 0, so 3 and -11 are the solutions. So the correct answer for this here is C. Into the caves. Which of the following values is a zero of the function? F of x equals 2x cubed minus 7x squared minus 15x. Is there any constant terms in this function? So, guys, let's wake up. One of the values that we do know that works is 0. Because if I plug 0 into this, well, 2x cubed would be 0. 7x squared would be 0. Negative 15x would be 0. It would zero all of those out. Do we have anything left over after plugging 0 in? Well, no. So 0 does work. But, again, the only one that we don't have as a whole number is answer choice B, yes? Let's go on and graph it and see what happens. So when we pull the graphing calculator up, we can hit y equals. So the first thing we have is 2x cubed. To do cubed, we use the caret key, or the key right above the division sign. That will give us exponents. Cubed minus 7x squared minus 15x. Hit graph. So as we said, 0 does work. There is a number over here between -2 and -3 that could be it. And then we have a number over here, 1, 2, 3, 4, 5. Second table. So looking at these numbers, the first answer choice is -5. When x is -5, do we have a y value of 0? So A is not it. B, -3/2. Is that shown on the table? No, but we did see a possible choice. C is +3. When x is 3, is y equal to 0? Nope, so C is not it. 6. Is the y value 0 for when x is 6? No. And the last one we have is 10. Is the y value 0 when x is 10? No. So out of all these choices, which one's left? -3/2. We will stop here. And the exit ticket will be whenever we finish this here. But with this so far, do the quadratics look a lot easier on the ACT than what they did before? Because if they're telling us whole number answers, graph it. Go on and graph it. Now, if we do have answers that deal with 1 plus or minus 2i or any of these here, quadratic equation. Quadratic equation will work. Now, most likely they may not give you in the plus or minus 2i. Most likely they're going to give you 1 minus 2i or 1 plus this here. Now, we went over this in the Algebra 2 class. If 1 minus 2i is a solution, 1 plus 2i is a solution as well. They come in pairs. If we have one, we have to have the other. We cannot have one without the other.